I'm going to start recording here because I know a few people are running a little bit late. There's been a bunch of updates to the calendar. I just want to bring some of those to your attention. As I promised, we are scheduling in new people to come speak. So I just got somebody who is like the director of something at a local shop called Table XI to come in to basically talk about how to make your app production ready. He's going to be coming in sometime in June. I haven't sent that over, but I think it's the 28th.
Is that John?
Yeah, it is John. Yeah. I scheduled in, so you have the option. You don't have to do this, but I would highly recommend it since it's free. There's going to be a person coming in to do an Agile training on June 23rd and 24th. And Agile, we talked about as a software development process. For large companies like John Deere and Pepsi and Coca-Cola and those kinds of companies, they're trying to move away from waterfall, which is like the old way of developing software, and they're trying to move into like more of an agile process. In order to do that, they need agile practitioners and people who can help guide their teams along the way. This particular training over this weekend is called Safe Agile for Scaled Agile Frameworks. And then he's going to be coming in to do a 2-day workshop over that weekend. So it is free. Everyone who has taken the course has passed the test, except for Rod, who got bored after the first day and left.
And it's not free. It's free to you. We've paid for it.
Yeah. Yeah, it's part of your all's tuition, and then he doesn't actually charge us any money where he usually could charge $150 an hour or something like that. He just says, I want to come and help. He's from Boston. He's just flying in. We're going to pay for his lodging and food and stuff like that. Sean, you had a question? No? Okay.
Is that available?
So this is unfortunately only for people in person. Remote, if you want to come up to Chicago, you feel free to come up and we can have materials for you and everything like that. I have seen on 2 occasions that the Agile training has gotten people employed at number of organizations. Whether or not you agree with these types of corporate trainings and you can get these certifications and stuff like that is beyond me. It's a personal decision that you're going to work through, but it has helped 2 students. They have attributed when I said that I had this certification, they were very impressed, and then that helped me get the job. I was like, cool. That's awesome.
It's just a 1-day training?
It's a 2-day training. And since it's over the weekend, we'll figure out what we're going to do with class that week, because it's just, 6 days of full days of class might be a little much. We'll figure something out.
I'm just wondering, should I recommend someone to come talk there?
Yeah.
I have a friend that's a lead at the Nerdery.
Oh, yeah, definitely. Who is your friend?
His name is Michael.
Cool. Sure, sounds good. Yeah, if you know anybody who you would want to come in and speak, just send them to me, and then I can schedule the talks in. It's always good to get more feedback and more, just meet more people than just me. But some things that are going to happen this particular week. Today we're going to do a Beyond Tech called Dealing with Stuckness. Actually, it might go tomorrow, pending how much stuff we get through. Our first assessment's going to be on Friday. And we're going to start class at 8 a.m. that day and finish 1 hour earlier. So again, we're just moving class up 1 hour, and then we're going to finish an hour earlier that day. Next week, Monday, we're going to start career coaching. So there's going to be a couple of recruiters coming in, one from a government agency called GSA, which is kind of like their internal startup for the federal government. And then the lead recruiter at a company called ParkWiz, which helps you find on-demand parking spots here in Chicago. Actually, I think it's everywhere. And then on Thursday, we're going to have a person named Chris Walquist come in. He's the equivalent of my boss at DRW. Been developing software for 25 years, was there when the original internet came out. He's going to be talking about Git. Then we have a SQL workshop from HashRocket, and you can just kind of follow along. Like, there's a bunch of extra stuff. I'm trying to add more and more as we go along. Pretty soon, we're going to have whiteboarding, people coming in for whiteboarding, most likely every Wednesday around 2 o'clock. So some senior developers are going to come in and teach whiteboarding as well. That's it for administrative stuff. Let's move over to recursion. Then we'll talk about, we'll review the binary search, talk about like libraries and things like that, and then that'll take us through the morning. So tell me a little bit about recursion. I watched the video yesterday that Josh put out. Tell me a little bit about what you know about recursion.
It's like Inception.
It is like Inception, but what does that mean? It is true. It's like Inception. If you haven't watched the movie, that doesn't make any sense. So I know at least one person here has not watched Inception. So what does that mean?
It's a method that calls itself.
Okay.
And then it builds up like a call stack of
Mhm.
things it has to get to.
Yep.
But the first thing, so the first item is not gotten to until the last item is gotten to,
Yep.
and the one before that.
Sure. That's pretty good. John, what do you
I
think?
don't know if I can't think of an Inception metaphor for it, but we learned the hard way that you cannot modify like an array and then pass it down, and then you can't get the original array back.
Okay.
So I don't know.
Okay.
You can't bring the spinning top back out of the dream.
You can't bring the spinning top back out of the dream.
If it's spinning, I don't know. There's no metaphor for it.
It's difficult to do metaphors for recursion.
I
Sean?
would say it seems like only parameters can hold on.
Yes, that is true.
That's so you have a very limited amount of things that you can do with those parameters, unless you want to get crazy with parameters.
It's true. Yeah.
You can do defaults though, and you can pass those around.
Kind of you need a base case
Mhm.
so that your recursion method has a way of escaping out.
Sure.
Otherwise it'll-
Pretty much. Yeah. I like all of these answers. We'll do one more and we'll jump into it, Sean.
So the thing that I think that I really realize using it is that it's very expensive,
Mm-hmm.
but it can do things that nothing else can do.
Okay. So what do you mean by it's very expensive?
I mean, so part of computing is how much memory
Mm-hmm.
you're going to write to and how you deal with that memory.
Mhm.
And so recursive function, depending on how deep you go, just keeps adding to the call stack, which is in memory.
Mm-hmm.
And it's not efficient. Like a loop is far more efficient for a simple task, but there's things that you will never be able to write enough loops to do that recursively you can do.
Mhm.
So that's my point.
Sure. Mhm. So I like all of those answers. I'm just going to summarize it as quickly as I can, and hopefully this can help you with interviews. I have worked in software for not like a terribly long period of time. I've only been in the industry for about 4 years, but I have used recursion 0 times. And anytime that I have ever written something using recursion, my boss has said, change this, it's not supposed to be recursive. And for that reason that Sean said, it's very, very expensive. Now, it's not like I have to take out $20 out of my pocket, but it's expensive in that it demands a lot of resources, where those resources could have gone somewhere else. Like I can do anything I can do recursively, I can do iteratively. 99% of the time, we'll just say 99% of the time, that is going to be the case. Anything you can do recursively, you can probably find a better way to do iteratively. Recursion looks a little something like this. If you've ever opened up like one of those windows, or if you stood inside of an elevator with mirrors on both sides, and you look, and you can look just as far down as you can see. Basically what happens is when I do a recursive call, I start out one layer, I go inside one more layer, that layer calls another layer, and so on and so forth, all the way back down to the very bottom. When I finally figure out my base case, I can escape, and then that has a value, and then I can go all the way back out. So in order to do any sort of recursive call, I first call it here, that calls another version, calls another version, calls another version, calls another version, and the first one is just kind of waiting until the very last version goes all the way back up the chain. Did we do that one exercise yesterday where everyone lined up in order of height? No? Okay. I'm going to explain this one thing, I'll get to Sean's question. So imagine for 1 second that everyone is standing in a line in height order, and the only thing you can see in front of you is the back of your person's head. Imagine you can't see anything else, like nothing off to the peripherals or anything. All you can see is the back of the person's head in front of you. And since that person is taller than you, you can't see anything in front of them. Now, the question you have to ask is, the question you have to answer is, what position in line are you? So, like, what is the base case? What is the escape case? Like, how do I know exactly which, like, how do I know when what position in line I'm in? So again, you're in a line. All you can, and the person in front of you is taller than you. All you can see is the back of the person's head. You can't see anything else. Your job is to figure out what position you are. So you need to ask one question to the person in front of you, and there is one base escape case. So what's the question that you're going to ask the person in front of you?
What position are you?
What position are you? All right. And if that person knows, then they can answer you, and then you immediately know what you are. But what's the base case? So yes, what position are you? And then what's the base case?
The front of the line.
The front of the line. The person right at the very beginning knows exactly where they are because they look in front of them and there's nobody there. So if you are the 27,000th person in line, you're going to ask the person in front of you, what position in line are you? That person doesn't know. He taps the person in front of him. I don't know. Keeps tapping, keeps tapping, keeps tapping, keeps tapping till they reach number one. Number one is the escape case. They know, oh, I'm number one because there's nobody in front of me. Then he can turn around, say, I'm number two, I'm number three, I'm number four, I'm number five, and it continues down the road. So recursion is the act of calling a method, like a method within a method, like the exact same method within the exact same method. So if I have a method called binary search, I have inside of my method, there's another binary search call inside of there. I need two things. One is a base and escape case. It's basically saying, when am I going to be finished with this particular bit of code? And then number two is that I need that recursive call. I need the same method to be called inside. So I wanted to go over binary search because I see a grand total of 0 pull requests. 2 pull requests, okay. That was not there 10 minutes ago. All right, so I'm going to grab it for now. And we're going to clone down. We're going to talk through our GitHub flow just like usual. I've got my 3 windows open. Going on. Okay. I'm going to git clone and download this from the internet. So when I do a git clone, it basically calls out using the first 3 letters. Again, git means that it's going to be a git command of some sort. Git clone basically downloads everything from the web from this particular link. It could be GitHub. Again, GitHub is just an online business. It's just a business. It's the name of a business. You can use Bitbucket. You can use GitLab. You can use Mercurial or something like that. That's a different software. But we're going to be calling down from GitHub. Once I've cloned it down, you can kind of see in the background right here that a folder appeared called binary search. From here, I'm going to change from where I am, because you can see I'm currently in desktop, into binary search. And I want to check out a new branch. So I'm not altering the original. I'm in my own little world. So I'm going to do git checkout -b John's solution for Foxtrot. Open this up in Sublime or your preferred text editor. A new version, I'll do it later. So I've got 3 windows. One is my Google Chrome. This will eventually be useful when we are seeing our HTML and our apps actually showing up on the internet. My text editor here in the middle, which is just a place to edit text, and then this place on the right just to execute little bits of code. Now, first things first, let's kind of read through a binary search. Binary search is fairly standard on a more challenging technical interview. More than likely, you won't be asked this, but it's a good idea just to know. So who can kind of explain to me what a binary search is, or a binary search tree? James.
So it takes a range of numbers,
okay,
and then it tests for the middle point of those numbers based on, I guess, the index, and then it checks to see if that's the match, and if it's not, then it looks if it's greater or less than. If it's greater than, then it throws away that first half and it goes to the second half, finds the middle point, and just repeats that over and over.
Sure. Okay. But what are you given? What's your input, and then what's your output?
You're given a number, and then your output is going to be the index of where that number is found, if it's
Sure.
available.
I like it. Okay. So a binary search is fairly simple. It is, I am giving you a certain amount of numbers. Let's say I'm giving you the number 357, and then I give you a sorted array of numbers ranging from 1 all the way up to 100,000. And let's say it's not inclusive of everything inside of there. Maybe it's just a collection of numbers just between 1 and 100,000. Your job is to go between these numbers, 1 and 100,000, and find where the index of this particular number is. So this works really easily if I give you like the number 4, and I give you an array of 1, 2, 3, 4. I give you the number 4, and your job is to find me the index of this number 4 inside of this array. Now it's fairly easy to see because there's only 10 numbers inside of here that the answer to this question is 0, 1, 2, 3. At index number 3, I find this thing that I'm looking for. If I change this to number 7, the answer is going to be 6 because it's at the 6th position in this particular array. 0, 1, 2, 3, 4, 5, and 6. There's my 7. This doesn't work if this array gets much bigger. Like we're talking like maybe 100 numbers, 200 numbers, 300 numbers. You cannot physically go. I mean, you can physically go inside of there, but it will drive you insane. And the idea is I want to use the computers to do as much as I can for me. So the idea behind it is, let's say that I give you the number 7, and we're going to do this using binary search. We find the number right at the middle. So we can round up, we can round down. It's up to you. I usually round down. So let's say we split the array right in half, so it takes me to this little line over here. I take that number 5, and I say, is 5 greater than, equal to, or less than 7? And obviously it's going to be greater than, so I don't need to even worry about looking through the first half anymore. The second time I go through it, I'm just going to do 7 with 5, 6, 7, 8, 9, and 10. I repeat the process. I cut it right in half. I round down, and I take a look right there. Basically what's happened here is I see this midpoint number is 7. Is it greater than, equal to, or less than this 7 that I have over here? It's equal to. Fantastic. I found the position. I need to know, 1, how far I've come so far. So it looks like I've moved forward 0, 1, 2, 3, 4 spaces. And then and then how many additional spaces did I move forward? 1, 2, and that gets me to this particular number of 6. So I'm going to continuously throw away half of my results so that I'm not looking through as like, is 1 equal to 7? Is 2 equal to 7? Is 3 equal to 7? Like that's called a linear search. I'm going 1 by 1 by 1, and that takes a very, very long time. When I split it in half like this, I'm just throwing away half of the things that I don't need at any particular given point. So with that, let's start writing some pseudocode. So step 1, again, I'm all about like easy wins. Write a method called binary search. What does binary search take in?
Sorted array.
A sorted array and
Desired value.
Yeah, desired value. The needle in the haystack that you're looking for. At the very end, we need to understand what's our input and what's our output. So James, you said it, like our input, John said our input was a sorted array and a desired value, which is like, I'm trying to find that needle in this giant haystack, that one individual number. What's my output?
The index of that number.
Okay, return the index of the desired value. First things first, I think the README was pretty clear on this one. First things first, I'm going to find the middle index of the array and the middle value at the of the sorted array. So again, in this example that we have here, I'm finding the middle index, which is, let's say 5 for now. And we're trying to find, so the middle index is going to be 0, 1, 2, 3, 4, and the value is going to be 5. What we're going to do then is compare the desired value against the middle value of the sorted array. We're going to do 3 different things. If the desired value is greater than the middle value of the sorted array, then, so it's kind of like 7. 7 was larger than this 5 right here, so I don't even need to look through this first half. I don't even need it. I can just throw it all away. So if the desired value is greater than the middle value of the sorted array, throw away the first half, just keep the second half, and repeat the entire process. So I know this repeat the entire process is either going to be a loop or it's going to be recursion. And since we've done recursion yesterday, we're going to recurse this at this point. Then we say if the desired value is less than the middle value of the sorted array, throw away the second half, just keep the first half, and repeat the process. If the desired value is equal to the middle value, return the middle index that we found over here, and we're done. Anybody see anything wrong? Do you think this is good? Do I need to do anything else? So again, I'm just finding the middle index. So whatever index is in the middle value, and I'm going to compare that to this particular number, so 5 against 7. If it's less than, which it is, I'm going to throw away the first half. Let's say we were looking for the number, I don't know, 3. And 3 is less than 5, so I can throw away the second half. And I'm just going to keep repeating and repeating. And I basically, once I get down to the point where I've split it enough so that the midpoint number is equal to this number that I'm looking for, I think I'm done. Or am I done?
When you throw away those values, you need a way to keep track of where you were.
Okay, so yeah, so Dan says I need to when I throw things away, I need to keep track of what I threw away. What case do I need to worry about when I threw something away? Is it going to be in this case on line 9, this case on line 10, or this case on line 11? Sean?
It really depends on what you're throwing away. So if you have to keep, no?
Oh, no, I'm waiting for the explanation.
I was just going to say, what you really care about is keeping track of which way you've gone in the array.
Yeah, which way I've gone in the array. So I only need to keep track of where I've gone if I'm throwing away the first half of something. Because if I'm throwing away the second half, all of those indexes remain the same. So let's take a look, for example, number 3. I find the midpoint number is number 5, and you can see 3 is less than 5, so I can just get rid of all of this stuff. So all I'm remaining with is 1, 2, 3, 4, 5. The indexes of compared to the original array are exactly the same because I've just kept the first half. But if I were to change this to 7 and this to 7, go back to what it was. When I throw away the first half of this array, 5, 6, 7, 8, 9, 10 is different, like at different indexes from the original. Like this one, it's right here in the middle. It's index number 2. But index number 2 of the original one was 3. So I need to keep track of how far forward I've gone. And in my case, right over here, I've gone forward 4 spaces. And you can see that this particular thing is at index number 2. I add 2 to 4, and then that gives me this 7th spot right over here. So basically, if the desired value is greater than, I need to throw away the first half, keep the second half, keep track of how far I've come, and repeat the process. Do we want to do this in JavaScript, or do we want to do this in Ruby?
JS.
JavaScript, cool, that's fine. Let's do that. Not an issue. Let's jump over here to binary search.
I always feel like once you do it in JavaScript, it's easier to translate it into Ruby.
That's because your first language is JavaScript. Okay, so first thing, call a method called binary search. Done. All about little wins here. Binary search takes a sorted array and a desired value. So I'm going to call, you can put whatever you want. I'm going to put desired value first, and then I'm just going to call this number. And then sorted array. We're going to change this real quick. So const this equals, we're going to change this into the ES6 syntax, so the fat arrow function. Again, the big difference was it's constant because these methods generally are not going to change. Called binary search. That is equal to, it takes in 2 arguments. One's called number, one's called sorted array, and then I have the fat arrow, which automatically binds the context of this, which you don't need to worry about quite yet. And then here's the body of the function here. First things first, we need to find the middle index of the sorted array and the middle value of the sorted array. Simple. Middle, we're going to call this let middle index equal sorted array dot length divided by 2. Is this correct in terms of everything, like in terms of syntax and everything? Yeah, John?
I would put in either math floor or math ceiling, depending on which way you're planning on going with the indexes.
Sure. Do you want to go up or do you want to go down? It's up to you.
I'd say let's lose the decimal by just going down.
Let's go down. Okay. So you're saying I just do math.floor and then this thing?
I mean, I don't remember the syntax, but
Yeah, I believe,
that's
yeah.
what I had to do.
I believe that's it.
Okay. If it's broken, we'll fix it later. All right. So we find the middle index, and then now we have to find the middle value. Let middle value equal sorted array at middle index. Yeah, John?
We should also sort the array at the start of the function.
Yeah, just to make sure that it's sorted, right? All right. So we'll call this sorted. We'll just keep the original sorted array equals. How do I sort something really fast inside of Java?
Exclamation mark.
Is it just dot sort?
Yeah,
Dot sort, open, close.
I don't know. Let's take a look. So I know some people are like, how do I Google for things? I know that I need to sort it. I don't know exactly the syntax for it, so I'm just going to Google it. How do I sort in JavaScript? Specifically, how do I sort an array of numbers in JavaScript? All right, so I'm looking here. I have different, like I Google things and there's 1,000 things that come up. You're looking for W3 schools, MDN, or anything from Mozilla is fine for JavaScript. Or you can start going to Stack Overflow. Again, the most reputable ones you're going to find are going to be W3 schools and MDN. The most reputable for Ruby is going to be W3 schools and Ruby docs. So it looks like there's some sort of a sort method, and you can just call .sort on it. Okay, so I will just, you can either try it yourself, you can take it at face value. I'm going to take it at face value for right now. I'm just going to do, it's not fruits.sort. I'm going to call this sorted array.sort. Do we want to name this the same thing or something different? It doesn't matter. It's up to you.
I would keep the name the same because you're going to want to pass it to the recursive function.
Yeah, it makes your life just a little bit easier just to rename, to overwrite the original. This is not always the case, but for now, I think we're good. So I'm going to add all my semicolons. Yes.
I mean, just to be like official about it, you could keep those consts, the middle value and the middle index, because it doesn't, you know, as recursive, it will still be right.
Yeah. So repeat that a little bit louder.
Just for the lets,
Yep.
you can make them consts. Like,
I can make these lets consts. Why can't I do that?
because every time it recurses, it's refreshed and it equals the right value.
Yeah. The middle, each time that I run through this particular binary search function, middle index and middle value are not going to change for that particular version. Like I'm not overriding middle index and middle value because those remain the same throughout each recursive call. So I've got a sorted array, middle index, middle value, and we're going to do a bunch of fancy stuff over here. So this is the main meat of it. So if the desired value, which is number, if number is greater than the middle value, I'm going to do something. Else if, it's else if, isn't it? Yeah. The number is less than the middle value. And then finally, everything else else if number is equal to middle value. So this first one says if the desired value is greater than the middle value of the sorted array, throw away the first half and just keep the second half. But I also need to keep track of how far I've come. So how do I get rid of if I have an array of like 1, 2, 3, 4, 5, and I just want 3, 4, 5, how do I,
It's dot slice.
dot slice?
Yes.
Okay. Let's take a look at dot slice. JavaScript slice method array. All right, it takes a look. It looks like it selects elements from arrays. Now let's just try it ourselves. So we have here on the left banana, orange, lemon, apple, and mango. If I slice between 1 and 3, my guess is I'm going to have orange, lemon, and apple. Let's try it. Orange and lemon. So it looks like it's inclusive of the first one, but not inclusive of the last one. 0, 1, 2, 3. Okay. So we'll try that out. So I know that I'm going to call it one more time. I'm going to do binary search. Binary search is going to take in the same number. I'm still looking for the exact same thing, but I'm going to slice the original array. So it looks like I'm going to do dot slice of, I need to basically go from the middle index +1, and then I need to go all the way to the length -1.
Yeah.
Yeah.
So I'm taking everything from the middle, going all the way to the end, and that's as far as I want to take it.
Or
You can, like,
is
do
it
that
minus? Is it -1 or just dot width because it's not inclusive of the last one? Is it,
I don't think you actually need anything there.
well, you have to pass in 2 arguments.
What is
For slice?
Yeah.
Is that a
It's
list?
the starting index and the ending index.
So if you don't actually put in it, just get
Let's find out.
Maybe.
Let's find out. Let's say that we have, so we open up the console right over here. Say, let A equal this. A dot slice, let's say we want to start from 0, 1, 2, so including number 3. 3, 4, 5. Yeah, nice. So we can just do this middle index +1. Cool. We're going to do that over here. And we're going to do that one over here as well. There it is. That's not it either. Oh, there it is. How does this look to people? All I did was just translate the pseudocode that we had originally, and I just translated it into regular code. I think I'm missing one portion, which is just basically keep track of how far I've moved and repeat the entire process. How do I know how far I've moved, and how do I keep track of it between recursive calls?
The only way that I know to do it is that you have to do another argument.
Do another argument. All right. So maybe we'll call this last index. I'll set this equal to 0 for the first thing, and then at this particular point, I can do binary search and then pass in. I think it's just middle index. If I'm not mistaken.
Yeah, I think you would be right too.
Am I?
Yeah, I think so because if we take the original array, we find the middle array, or I'm sorry, the middle index. At that point, it would just be whatever that index is. You add that to it. Maybe it'd be middle index -1. Eventually.
Okay. John, what do you think?
I did have to do -1 +1, but I did a different way of getting middle index. I think. Oh, I mean, I did a different way of calculating my if-else chain. So I think I think the way you route it, you could probably just keep it as middle value. And if the brackets don't connect ever on a single value, then then change it to +1 -1 2.
Okay, we could try that a little bit later. Okay, so for this one, I have to keep track of how far I've come, right? Because the number is greater than the middle value. So 7 is greater than this middle thing over here. So I need to keep track of how far have I come so far. Since I know that I've split it right down the middle, and this 5 here, I have that index. I'm just going to pass it in here because that's as far as I've come so far. Now, what happens if the number is less than the middle value? So the next time through, let's say I gave you 6. So I've come this far, and I take the middle value here, and I say that it's 7. I know that 7 is greater than this 6 over here. So the next time through, it's 6 with 5, 6, 7. I've thrown away this first half, but I have not kept track of the first half anymore. I no longer have how far I've come originally. So what I need to do is add one more small thing. I think it's just last index plus middle index. And otherwise, I think we're good. Let's just run it and see what happens. I'm pretty sure this will break. Node binary search.js. Everything is false, true, false. Okay, everything is kind of messed up. I'm going to move a few things around and add a few things just so we can continue on and get to today's topics. And I'll explain it in just a second. So if we sort it first, we find the middle index and the middle value. I'm going to do a few if-else statements. If middle value is equal to the number, return middle index plus last index, else
I don't think last index plus middle index is going to work.
We'll find out. Let me just compare real quick. Yep. If the number is greater than, going to different item. Excuse me. Just run this real quick. True, 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 false, false, false. Let's see.
Wow.
Just a second. I think that's it. Maximum call size exceeded. All right, so let's just review this real quick. What I've got here, I'm not sure what's broken. I'm sure it's just like a plus or minus one or something like that. If you see it, please call it out. Basically what happens is I'm going to give you a number. Let's bring this back over here. Sean, do you see what's wrong with it?
No, well, the thing is that I didn't know that you could do it with just one extra parameter. I used two.
Cool. Yeah, you can do it with one extra parameter. So I give you a number. Let's say it's 6. I give you a sorted array, and then I start my last index at 0. I'm going to find the middle index and the middle value. For us, it's probably going to be the middle index is going to be 4, and the middle values is going to give me 5. If 5 equals 4, 5 equals 6, which is what I'm looking for, which is not true, I'm going to skip this portion. Else if it is the length of the array equal to 1, nope, skip that one. If the middle value is greater than the number, which is also not true, and then finally I end up here. The middle value is going to be 5, and it's less than this particular number so far. So I'm going to rerun this with the same number I'm looking for. I'm going to slice it from 5 all the way until 10, and then I need to keep track of how far I've come. So that middle index, I've come forward 4 spaces, plus the original 0. So I've gone forward 4. At the next point, I end up at 6 with just 5, 6, 7, 8, 9, 10. At this point, I'm going to take a look at the middle index. That's probably going to be, looks like it'll round down to give me, I think, 8 actually. So this is my middle index, and my middle index is going to be 3, and my middle value is going to be 8. I come all the way to the point where the middle value is greater than this particular number, so I'm going to keep track of the number I'm looking for. I'm slicing between 0 and that middle point right here, and then also the last index, which is, for us, it's 4 so far. So this was 0, now it's 4. Go one more time with 6, 5, 6, 7, 8. And we've come forward 4 spaces thus far. And then we keep splitting until we finally get to the point where the middle index at this particular point is, the middle value is equal to that. So we're going to say return middle index, which I think is 1, plus the last index, which gives me 5. Not sure why this is broken at this particular point, but I will send this out.
I think it might be line 12.
Line 12.
Because we weren't able to find an easy way to sort numbers.
Okay.
And in JavaScript, the sort function actually sorts it alphabetically. And you have to do something else to get to sort numbers.
Okay.
You just
What?
have to put it's a callback function. Just put A plus A.
That's right.
Yeah. So if you just, but since it's already sorted, if you just turned off line 12, then that worked.
It's actually not already sorted.
Okay.
So what do I have to do?
It's A and B in parentheses, add arrow, and then I think it's A minus B, I believe.
Like that?
Yeah, but you have to put those in
brackets, not or in parentheses, not in.
Oh.
No, like that it has to be parentheses. The whole thing. It's like dot sort parentheses,
Mm-hmm.
open parentheses over. No, you were.
Okay.
Very good. So another set of parentheses in there, A, comma B, then that arrow, then what you want. No, you don't need that. So I think it's A minus B.
Let's find out. True, 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 false, false, false.
So that could be wrong. It could be A greater than B or A1. I just don't remember. There's 4 or 5 ways you can do it with that.
Sounds good. Either way, rather than beating a dead horse and figuring out that one tiny little thing that's wrong, I will send out my answer, both the JavaScript and the Ruby, so that everyone can see it. Let's take 10. We'll be back at 10 o'clock. We'll cover the stuff we need to cover for today.
Do you have questions?